Okay, today we're gonna talk about the third tab in our foldable, which is and or, which is on probability, and we're gonna focus on that today. It can be a little bit tricky with the and statement, so again, write all the notes down. You'll have some questions throughout the foldable that you'll have to answer that are multiple choice. Okay, and versus or. So this is the probability. When you have an and statement, that means two things are happening. You want to know if something happens and something else. So in this case, if you read it, when you see the word and, you multiply. Okay, for an or statement, that's only one thing happening. You can say, I want it to rain or snow today. Okay, so you only want one thing to happen, but it can be either one, so it's one statement. So for or, you're going to end up adding. Okay, you're going to end up adding two things together for an or statement. So up here, the tricky one to do is the or statement. That's the one we're going to look at first. If you look up here to do an or statement, you're going to add the probability of the first thing happening plus the probability of the second thing happening minus the probability of both happening. And you subtract the probability of both happening because otherwise you're going to be counting the same thing twice. Okay, and I'll try to explain that when we do the problems. So if you remember yesterday, we talked about this chart that talked about basketball and soccer players that were men and women. It was a survey. This is the same chart filled out. So you may at least want to write down view chart on tab before, okay? But I would at least write the questions down in your foldable, okay, so you know what you're doing. So let's go ahead and look at question number 1. So it says, how many men or basketball players were there based on the chart? So the key word is or. So they can be a man or they can be a basketball player. So if you go by that formula, I'm going to go ahead and find the number of people surveyed that were men. Okay, the number of people that were surveyed that were men, just men, is 21. I'm going to add the number of people surveyed that were basketball players. Okay, that were basketball players. So the total number of people that were basketball players were 30. What you have to do is you got to subtract out where they overlap. You got to subtract out men that played basketball. Otherwise, you're counting those people twice in the survey. So men that played basketball, okay, overlaps right there. So there's 6 people there that I don't want to count twice in the survey. Okay, because I counted men and I counted basketball already. So I'm counting 6 people twice on accident. So I want to subtract away 6. Okay, when you do that, 21 plus 30 minus 6, you figure out that's 45 people. Okay, so 45 people fall in that category. Okay, number 2 up there, there's no or word. It just wants to know how many women's soccer players there were. We did this one yesterday. Okay, I just want to figure out where women and soccer overlap. They overlap right here. So 5 people were women that played soccer. Okay, so again, not an or statement, so I don't need to add 2 things. Number 3, how many basketball players or women were there? Okay, again, I have an or statement, so I got to figure out how many basketball players and how many women and add them together and then subtract away where they overlap. So basketball players, the total number, we've already done that, of basketball players is 30. Okay, the number of people that are women total, which I'll circle right here, is 29. And I need to subtract away where they overlap, which is where you have basketball women, okay, women that played basketball. So they overlap right here. There are 24 women that played basketball. So again, I don't want to count them twice. So 30 plus 29 minus 24 tells me 35 people fall into that category. Okay, 35. Okay, the last 2 down here, you have a P in front. So that's probability. So if you remember, that means you're going to have a fraction. Okay, the total number goes on the bottom. Well, if you look up here, the total number of people surveyed were 50. So that's going to be something out of 50 before I reduce it. Okay, so I can go ahead and put that there. All right, number 4. Wants to know the probability that somebody is soccer, okay, played soccer, or is male. So again, it has the or statement. So people that played soccer, okay, people that played soccer, there are 20 total people that played soccer. So 20. Okay, as far as the number of males, there are 21 total males. And then I need to subtract where they overlap so I don't count it twice. So male soccer players, Okay, male soccer players is 15, so I don't want that to be counted twice. I'll go ahead and subtract. So when I do that, I end up finding out that is 26. So 26 out of 50 fall into that category. And if I reduce that, I believe that's 13 over 25. Okay, so there's that one. Okay, the bottom one, again, it's an or statement. It wants to know how many people were basketball or women. Okay, basketball or women. So they write this one in red. So the total number of people that played basketball right here is 30. The total number of women we already did, which is right here, that's 29. And I need to subtract away where they overlap, which is women that played basketball. So women that did basketball, again, is 24. Okay, so 30 plus 29 minus 24. So 35. So 35 out of 50 fall into that category. And if you reduce that, you end up getting 7 out of 10. Okay, 7 out of 10 for that one. Okay, when you don't have a chart like we just did, you don't have to worry really about them overlapping because you can physically see the numbers, so you don't have to take that into account. So this will be a little bit easier when they have the physical layout up here. So let's go through. Again, all three of these have a P, so they're all probability questions. Okay, so I'm going to have a fraction bar. And if you look at it, it says I fill to have with the following numbers. Okay, 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers, okay, that I'm going to draw from. So my denominator should originally be 10 on all of them. Okay, before I reduce. Okay, number 1, it wants to know the probability of getting a 2. There's only one 2 up there. So it should be 1 out of 10. There's a 1 out of 10 chance of getting a 2. Number 7 up here, the probability of getting a 2 or a 7. So you can get either one. Okay, 2 or a 7. So that's two different numbers. So you have a 2 out of 10 chance of getting a 2 or a 7. Okay, and that reduces down to 1/5. Okay, number 8, the probability of getting a multiple of 3 or an even number. Okay, so this is where it's a little bit tricky, but let's do multiples of 3 first. So 3, 6, 9 are all multiples of 3, or an even number. So 2, 4, 6, 8, and 10 are all even numbers. Now notice how 6 up here, you can't count twice. Okay, and that's why we used that formula before. You don't want to count 6 twice. So numbers that fall into that category are a 2, a 3, a 4, a 6, an 8, a 9, or a 10. Okay, I can only count each of them once, but they're either an even number or they're a multiple of 3. So that's 1, 2, 3, 4, 5, 6, 7 out of the 10 numbers, okay, fall into the category of being a multiple of 3 or even. But again, that 6 overlaps. You can only count at one time. Okay, you can only count at one time. Okay, this right here, you don't need to write down in your foldable. It's just a reference. These are playing cards. Okay, so just so you know, there's 13 cards of each type of suit, okay, which has them listed here. So you have an ace all the way to a king of each type of suit. This first suit up here, the black cards on top, these are called clubs. Okay, and the next group in the middle, the second row down, are hearts. The third row down are spades, and the fourth row down are diamonds. So again, if you're on Math Excel and you need a reference to this, okay, you can go back to Edpuzzle, click on this, and this will show you cards in the deck to answer the questions.